Yeah, hi, this is Coffee Compiler Club. Anything to do with compilers and language runtimes and garbage collection and typing systems and performance and implementation of languages. It's all fair game. Open mic, ask what you want. I don't have a set agenda. You're being recorded live. You show up on YouTube within a couple hours generally. I don't have anything else to say at the start other than that we have an agenda already. So I'm going to turn it over here. You're up, Kirk.
Yeah. Wow. I hope it was a fun week for everyone. Got it. Okay. No, right now I have Zoom telling me stuff that I didn't really care to know, but you have to get it out of the way, right? Yeah. So the question I posed last week, and unfortunately there's not a lot of people here to answer it.
A bunch of people said they're going to show up, but later.
So I was talking about the effect of memory layouts on performance, and this is actually where I got hit. Oh, Cameron's here, so he can laugh at yet another demo failure. So I did this demo at JFocus. It's a really nice demo. So basically, what happens is I have this web application. It's kind of like poorly tuned at the beginning, like the JVM, and then what I do is I dump some load on it, and performance is like shit for a minute or so, and all of a sudden and the CPU is like just basically pinned, and all of a sudden like boom, right?
Boom meaning you get performance now.
Oh yeah, like the CPU
so this
drops
is just like the standard jitting curve at startup.
Oh well, it's actually more than the jitting curve, right? What you get is a rearrangement of heap spaces. And the rearrangement of heap spaces actually allow for the garbage collector to settle down. And it's really the garbage collector interference that's really causing the issue more than the JIT experience, right? So anyways, so I get the optimization I need in the JVM, and all of a sudden my responses are milliseconds, single digits, really everything's wonderful. And my CPU now drops for the load down to about like somewhere between 10 to 20%. So it's like, it's awesome, right? So anyway, so I have this demo and it works really, really wonderful on my laptop, and I kind of go up on stage, do the presentation, and in the middle of the presentation, I run the demo.
And it doesn't do the same thing.
It doesn't, it just doesn't work, right? It doesn't work.
Yep.
Demo doesn't work. And so I'm sitting there going like, because
been there,
like,
done that. Yep.
Been there. Okay, so it doesn't work. And then so I get rid of everybody as soon as I can. I'm in the hallway, trying and I'm going like, okay, now why does it not work, right? And I run it, and the damn thing works.
Right.
And now you have this situations like one of these things is not like the others, right?
Yeah.
So to go back to Sesame Street, and so I'm thinking like, okay, so what was different there? So, oh yeah, so I was running Keynote and some other things. So like bang, 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 run it, failed. Shut everything down, run it, works. Start everything up again, run it, failed. So now I have a consistent failure, right? Because all I know, so I'm figuring out, okay, so what's going on here? So what's happening? Because Keynote's not doing anything, right? It's doing nothing. It's zero CPU. So the only thing it's doing is like basically taking up memory, right? Which means that my JVM is now being pushed up in the address space. So we're no longer in the 0-page address space. We're like into like basically up into the third and fourth quadrants of memory.
Well, another effect is that the JVM starting memory heuristics say how much free RAM is available. Let me take 3/4 or half or something.
No, I don't. I factored that out because I set the heap size, because this is one thing. Part of the demo is that you get better performance when you set a smaller heap in this particular case than when you create a larger one.
Sure.
Okay. So basically, what part of the messaging was like getting an optimal size heap is better for performance than just adding more memory all the time, right? So actually, with 2 gigs of RAM, this application ran noticeably worse than if I gave it 1 gig of RAM, right?
Okay.
And the optimization would apply. So I don't have any of those, all of a sudden I have less RAM because issue. This is strictly I'm now laid out in a different quadrant of memory.
Okay.
And we know that the upper fourth quadrant of memory has much less, it's much less efficient in terms of its addressing schemes.
Yeah, okay, fine. I would claim no, but
what's that?
There's no difference. The JVM doesn't generate different code.
It doesn't generate, you would think it doesn't generate different code, and it shouldn't.
Yes.
But I think it actually does, because the heuristics that drive the optimization are affected by the timing issues, and the memory timing issues are just slightly different, that I was getting the optimizations weren't being applied.
Okay, so
that's my guess. It's a hypothesis. No, but so I'm looking for, so I've always been, curious as to.
So I can tell you how to tease apart the different effects here, but I can't diagnose it with no information on the fly, not enough information on the fly. So it's highly unlikely that you got different code directly generated, because the addressing modes and the instruction offset constants, whatever, they don't change here. They're not affected. It can be the case that you got some other effects triggering inlining badly that cause endless deop loops or endless fail to correctly inline. And that one turns into your CPU performance bytes and shows up on profiles that what was 0 load in the CPU is now high load. There's another version of things which has the garbage collector heuristics didn't settle down, and he's endlessly turning cycles, or he's choosing poor quality GC points instead of high quality.
That's the one. That's the one that was happening, because the optimization wasn't applied at the expected time.
Okay. When you say the optimization, you mean some sort of memory optimization?
The memory optimization.
Yeah, okay. So maybe a thing you could do is write a little program that eats a very large chunk of RAM that just hangs onto it till you kill it. So what your proposing keynote is doing, which could be legit, and run some powers of 2 sizes on it, and then start and run your load and see if you can discover either where it lands or how much memory you eat before it starts to screw around with you and not do the right things.
That's a good experiment.
And replace keynote with do nothing empty. This is Gil-10A's like jitter meter, like what the fuck, we're trying to look for low pause times in the GC. We have all these pauses. So first diagnose that it's not the GC or it's not the keynote by just getting rid of it, and replacing it with.
Yeah, that's absolutely not the case in this case. I really nailed it down to the memory optimization that I was expecting in terms of reproportioning of memory pool sizes, which allowed
that comes out of your GC
to be collected in young. Yeah, so
that comes out of your GC logs.
Yeah, that's all you do. You just get the GC log, do the analysis. You can
so you've seen that it's failing to optimize, and now you're asking what's the heuristic and why didn't it kick in?
Yeah, that's and why is that based on where the layout was? Now I'm going to add another data point in here, if you don't mind. So and this comes from like a quote unquote best practice from Netflix, and it's not only Netflix that applies, but other people do, right? They will look at the time it takes to load a JVM and get it to basically print the hello world statement out. And if it takes longer than a certain period of time, they'll just go and kill that VM, because they know that that VM will not perform for its lifetime. If their load time, the time it takes to load, and to the time they get like hello world printed out. And there might be a whole bunch of different reasons for that, but when I'm looking at, so we're looking at the vanity metric now for some stupid reasons, startup time. And
vanity metric, I like that.
Yeah. Anyways, yeah. And so if you get a time budget as to like a real time budget breakdown of where startup time goes and stuff like that, you can clearly see that there's very little you can do in the JVM to influence startup time. Very little. You can whittle away at the edges.
Yeah,
but that's not where the time budget is being consumed. It generally is in the kernel and the operating system stuff that's going on.
Right.
Anyways, but the point is that Netflix is basically as part of their startup protocol. They just measure how long does it take to start up the process, and if it takes more than a certain amount of time, they just kill it right out of the box and restart it someplace else.
Yeah, I
That-
claim that they've chosen to not diagnose some more fundamental issue, which is
I-
fine.
They haven't. So this is their tactical hack to
Yeah, right.
not do the pure diagnosis. But one more data point is that I went and asked Oracle, I said, do you test by pushing the JV around in memory? And their answer is no. They don't run different benchmarks by pushing the benchmarks around in different quadrants of memory.
Who did you, I'm sorry, who did you go ask for this?
Well, at that time, it was the performance engineering team. I guess most of them are in St. Petersburg.
Yeah. There is a well-known screw around of process start, wherever the start is, landing on what kind of page and TLB boundaries. So if your JVM starts mid of a 2 meg TLB versus forwards or backwards or slightly more or less off, the starting stack crosses bad TLB boundaries or doesn't, and turns into having performance issues. That was you know, I can drag up the paper for that one, doing bad things without doing bad things or something. It was a funny title. It was all perfectly good. It was a prof discovering that the name change between his student and himself on the ENV caused 20 to 30% performance change on this particular benchmark they were trying to diagnose.
Sorry, was it 20 to 40%?
20 to 30%.
Okay, that's on the low end from what I've seen.
I'm just saying,
yeah,
we have a well-documented, well-diagnosed, well-situated where sliding you a couple of bytes, tens or 20s of bytes, caused this guy to span a TLB boundary, and the x86 iCache fetcher refused to cross a TLB boundary, and the hot inner loops all refused to get iCache prefetched because they were crossing a TLB boundary and performance was significantly impacted. So now what does that mean? It means that if you do these other layout games, and you can go ask, who's the guy in Massachusetts that does it? Not Bill Pugh, the other one. Emery Berger.
I know who you mean. There's another guy. I know who you mean now.
I meant Emery Berger, but there may be another guy.
Yeah, yeah, that's right. It's Emery Berger. Yeah.
Okay,
Emery
yeah.
Berger.
So he does these great jobs where he forces page layout random swapping constantly in order to get a steady baseline where you basically defeat randomness with statistics. And then you can argue that, you know, you're hitting the statistically good case versus statistically bad case on your laptop. And then you can decide whether or not it's something you want to tell people that this works or doesn't. Or maybe you've discovered something else, like the heuristic involved is magically broken if the power of 2, like GCs are full of things where they take address page offsets as integers and do bit tests on which power of 2 you're higher or lower, and they've got something screwed up. And they don't handle a case, and suddenly the heuristic doesn't kick in when it should, and you're not getting your layout reorganization.
Yeah,
I'd start doing page layout forcing.
Interesting. Okay.
So how feasible is it to get a runtime to do experiments and try things and pick the one that works best?
Well, Emery Berger is really good about pushing his stuff out, making it readily available and stupid to use. Like he takes random C programs. JVM's a big fucking random C program. And he says, I'll look at your address space claim layout and I'll do page remapping under the fly on you.
Yeah.
And he's well aware of the issues with Java. So I am certain he either will say it doesn't work for JVM, or he'll say it does and I made it work. Right?
It doesn't work for a JVM.
It doesn't?
No, there's some that used to work for a JVM, but now, but there's some work apparently that needs to be done to recover it for a JVM.
Ah, so you already found the link.
Oh yeah, that stuff I found. That's
okay.
wrong.
Well, that was my best guess at what was the right way to go hunt this one down.
Yeah, but it does say that some of the performance optimizations we apply probably are really fragile, simply because what happens is that you add a few extra bytecodes, or you take out a few extra bytecodes or instructions, and then bang, all of a sudden you get the alignments that you need or the alignment that you don't want.
Well, I'm like very much of the opinion that there's no code generation change per se, not directly.
Yeah, so it's an alignment issue.
And so it's a GC has triggered some heuristic that it's refusing or trying to reset. Yeah, Yeah, and that turns into an alignment, but not with code
Yeah.
generation per se.
Yeah, absolutely. So I don't think it was like code generation. It's probably, you're right. It's probably like an alignment issue. And because of that, you're not getting the reorganizations that you need to happen.
Yeah, right. And that was the proposal, get rid of Keynote, was to, just have a stupid thing that you could diddle with more carefully on.
Yeah, sure. Because then you could progressively push it up until you hit a boundary.
Right.
Yeah, exactly.
Right.
Where Keynote just happened to do the job.
Yes, exactly. Right. And then I'm just trying to say, let's not blame Keynote per se, but blame the consumption.
Right. No, it's not Keynote's fault. It's just how things got laid out.
And then, did you try to run the did you run the code on Linux or on Windows?
I actually ran an OS X, but I have run it on Linux.
Okay. Did you try to perf record to record all the events that happened during the code execution? Because perf records all the things. It doesn't matter which does it pin to a process. It records all the code that's it is executing up to a way to the kernel.
No, I actually haven't done anything like that. I'm not sure what you'd hope to see from that, but because I don't think it's a code issue. I think the exact code gets run. It's just
because the time has to go somewhere. Either some function does execute more times.
No, the time goes in the losses
heuristics.
GC. So for instance, if your live set has a particular pattern where it comes and goes in size, and the GC waits long enough to where it goes, the live set dies, then it runs a cycle, all that shit's dead, and the GC does no work and cleans it up instantly for free.
Right.
And if instead your live set, because you're applying load to some web server, spans a GC cycle, then everything that's in process for those particular web requests remains alive for the next GC cycle. And suddenly the GC can be doing a lot of extra work or not, according to,
Yeah, you get premature promotion of transients, right?
Yes.
And that's really that's the root of all evil in this case.
Right, which I claim that, the larger heap should rescue you that one. If that's actually it.
Well, the larger, okay, so the larger heap actually semi-rescues you. So by making it larger, you're going to win on one end, you'll get a loss on the other.
Yeah, you lose on the other end too. Yeah,
so a reproportioning of heap actually is the win, because you can keep the tenured size down, which doesn't affect your linear scans times.
You want a larger young gen.
But then you use a larger young gen and everything like that. And that's what the optimization that I was trying to apply would happen automatically. So it would become adaptive to load.
Yeah.
And they said that, and that was the failure. The failure was that the adaptive resizing didn't happen.
Yeah. Right.
When we pushed the application up into higher memory address space.
That's interesting that it was memory address space bound. I believe you on that one. It just seems interesting. I know that Michael Wolf at Azul did the heuristics for the, Azul collector, and he wrestled for a long time and finally dove into sort of deep control theory on how to prevent overdamping, underdamping control signals to get a reliable, when does the GC kick in and when do you promote and when you do this and that. There's some interesting theory, but you go to fluid flow or control flow dynamics theory. Okay. There is a well-known study theory here, because every analog system on the planet does this shit all the time.
Right.
But it's not a comp sci staple.
Right. Yeah. So in that case, having cross discipline is actually quite useful for some of these problems.
Yeah. Right. Yeah. Yeah. Go wrestle. See if you can shove it around. What was the other one that Gil did all the time? He would do this weird shit where he would put giant holes in your heap. Right. Making a bunch of big allocations and then freeing, every other one.
You would alternate big and little.
Yeah, that's to fragment.
Oh, yeah, the fragmentation portion. But you're thinking that's not what you got here.
The allocation rate.
No, that's not what you have here.
He'd somehow keep the allocation rate high enough that he was basically forcing a starvation on the collector somehow. I can't remember the details.
Right.
Yeah. Well, the fragmentation. Well, so what he was trying to do is break CMS, right? So JFragger
CMS, but yeah.
Yeah, he was primarily targeted at CMS. So there's JFragger, which is basically you run it. you run it with your application, and it just works in the background, and it just completely
tortures the collector.
it tortures the collector.
Yeah.
So yeah, I actually use it in my workshops because I get people to clean the garbage collector with JFragger running in the background. It's really fun.
Oh, interesting. Interesting. Okay, fine.
Yeah.
I'm glad it found a home. It seemed like a cool concept. I know we used it on a Zool collector just to validate that it was doing the right thing.
Right.
Yeah.
But you can do that with G1 also, right? Or I haven't done it with ZGC yet. Or
yeah, I bowed out of that game a while ago, but yeah, I know that people were screwing with it at G1. I certainly haven't looked at Shenandoah or anything like that. I have no idea.
Yeah. So, but anyway, so the point being, it's that's a fragmentation issue, which is I think completely different in this here, because this here I think we had a lot of really like most applications have fairly uniform allocation patterns.
Right? Yeah. I was H2O big data. I had two allocations. I had giant multi-megabyte byte arrays for big data, and I had lots of tiny control structures.
Right, exactly. So the tiny control structure probably dominated. Yeah, so since we don't have a proper way of measuring allocation rates in the JVM or anywhere for that matter, well, because everyone takes the measure by volume.
I say your kit would argue differently, but fine.
No, that everyone reports by volume, and that's
they'll report by allocation too, by count of direct allocation.
Yeah, some of them do. To be honest, yeah, some of them do. But even those numbers are somewhat estimated, and also in the process of reporting that way, they screw with the numbers. Right? They blow escape analysis.
Oh, that may be. Yeah, that's interesting.
So all of the profilers except for JFR blow the escape analysis. JFR is how it measures its allocation is just biased very badly. So anyways,
your kit says they sample at a low frequency, but I bet you they inject, and that will blow your escape analysis.
Yes, that's exactly what happens. And you can see this because normally if you do a study of the profile afterwards by looking at the compiler output, you can see that there's is that you just miss the the scalar replacements, and yeah, all the scalar replacements won't work after that.
Interesting.
Yeah, I imagine if you hook and replace malloc, you've introduced a direct call in every malloc. Additionally, that's going to mess with your performance. No.
Yeah, right. It actually is going to mess with your performance, and there's probably a way to sample this, but to cope with that. But my estimation is like a good allocation rate in JVM is something in the order of 4,000 to 5,000 allocations per second.
Boy, that sounds very low.
Yeah, well, you could see it. You can see it over the years because it used to be that with a quote unquote normal functional application, the allocation rates would tend to max out at about 4 gigabytes per second. And so we look at the GC log and say it's 4 gigs per second. And then if you assume that every allocation is approximately the same size, then you can do the math on it and then get an idea of like what the allocation value is. And that's why you could see it like basically top out. And if you get a mix like with your application, where you get like these humongous allocations, massive, right? So you just get like, like spikes in that.
Yeah, we had interesting spikes. A lot of the data was long-lived, but not all of it. They're definitely like the original big data was stable hit. But
yeah, so today you take the same benchmarks and you run it like JDK 17, you'll see a max out at about 8 gigs. So over the years, it has doubled. But if you start putting metrics in there to measure all this stuff, then yeah, you're right. You're going to screw with it very badly.
You think a lot of that's due to? I thought escape analysis wasn't very productive.
Well, no, it is really productive. It's not as productive as it could be. So we have actually one guy in our team is working on improving escape analysis. Especially they're trying to do more of a like a call stack type analysis as well as like stack based analysis. So that you can get things that you can't inline, but basically they represent leaf nodes, In other words,
Right,
you can safely
right.
escape.
Right. Well, that was my escape detection versus escape analysis being highly productive.
Right. Yeah. So it
Work
works
with
fairly well
practice,
now,
theory.
but yeah, it actually could be better. But anyways, you know, back to the main point is that the profilers either disrupt this or we don't get really good data.
Interesting.
All
right.
On that.
Yeah, I don't know a good way to say, Mr. Profiler, you can do anything you want, but you can't schmuck with the code generation ever.
Right.
And then, you know, to Aaron's point, that there is a way to reduce sampling overheads by flipping, by putting the sample test at a high enough point in the call stack that it gets executed infrequently, that it's low cost, and then it periodically flips you to a heavier weight version, which samples.
Right.
But that gets more and more complicated and harder to get a true, but you end up sampling the sample generated version that has sample points in it.
Right.
And that version is different than the one that you're running 90% of the time for performance.
Yeah. So my last point on all of this is that I think the difference is now due to GC barrier costs. The GC barrier costs have just been dropping over the years.
Well, most people didn't do read barriers, and write barrier costs were always fairly low. They ate bandwidth, but they ate bandwidth, but they had no direct costs. Every write of a pointer would require an extra like clock cycle on an x86 worth of work plus bandwidth.
Okay. It's the other work that you have to do also, right?
Well, that's the main direct costs for a barrier. Read barriers.
I thought the main cost was that you couldn't predict through them.
I'm sorry?
I thought the main cost was that you couldn't predict through them. So
right
it limited the depth of branch prediction. And
no. Write barriers for GC is when you write a pointer and you have to inform the collector that a pointer got mutated. And the standard way you do this is a card mark, which is you take the address you wrote into and you shift it right by 512 for 20 years for hotspot, but pick a number. That's a card. You get a new address, which is a card, and you write a byte.
Yeah. And
the collector comes along and inspects these cards, and every time he sees a byte, he knows he has a mutated pointer within a 512 byte range. So it's a way of allowing the collector to have much less work to scan for changes.
Right, and it's also a good way of creating false sharing.
Right. So the Azul collector, we went to a filtered card mark, and I think Hotspot on and off has experimented with filtered card marks. So you're always writing a 0 byte. So you pre-fill the thing with ones. You always write a 0 byte. You write a byte, not a bit, because x86 will atomically write a byte without any false sharing, without any line shearing, without any shearing, not sharing, shearing. Totally, you get false sharing if multiple threads are beating on unrelated pointers, changing them rapidly, but the card marks tie on the same page, and they're constantly writing a 0 on the same cache line. Then you get false sharing there, which you fix by filtering your card mark. Because once you write a 0 to that address, you never have to write another 0 again. So if you read it and it reads a 0, you can cache the card mark as a 0 line in your cache. You test it's a 0, you don't write anymore, and you quit emitting writes to the same line. Everyone's now sharing the line. They're reading it in their cache constantly. That one's cheap. But then you have, a little more complicated, a little slower write barrier, unless you have false sharing issues or you ran out of bandwidth. So if you have a big, heavy server with a lot of threads running and everyone's doing heavy GCs, every little bandwidth costs. If everyone writes, every time they did a pointer write, they wrote, then you have a steady stream of writes going out and eats up your memory bandwidth.
Yeah.
So no free lunch.
Why do you write zeros when you do the card marks rather than setting the byte to 1?
Well, it doesn't matter, except that the 0 byte can be done with a fewer, shorter, smaller instruction.
Okay.
It happens every time there's a pointer write. So it's kind of common. Like reads are 5 times more common than writes, but writes happen. So code volume issue. x86's old school instruction parser or whatever will always shortcut those versions of the instructions.
Okay. I think we were writing, we were using the opposite pattern. You were writing a 1 into the card mark.
Yeah, people do.
I was just curious why.
But yeah.
Shorter instructions, that makes sense.
Shorter instruction, yeah, there's no other reason really. You have to have a one, you have to manifest a one somewhere. So it's in the instruction as a constant, or you put it in a register or something happened. Either 0, there's a shortcut. Most
I assume that's architecture specific though, that ARM basically won't care whether you're doing
it
1 or
is,
0.
except that many architectures do the 0
Double
special.
Yeah, so I mean, you have to move immediate 1, which is an extra byte.
Right,
And with 0, it's a 1 byte up.
right. You always shave something off there, or at least in nearly every architecture I've ever looked at, you can get a 0 cheaper than you can get anything else.
And the other thing, that the CPU designers are constantly optimizing for the 0 case because it's the most common case.
This is the most common case.
They're not going to
Totally.
optimize for setting it to 1 or some DB value, defined byte. Yeah.
Yeah, the Zool collector, Zool hardware actually went to the point where our write card mark filtered in the hardware. So that was a cool hack. It was going to write a 0. It was going to read the line into your cache and check, and then not bother to write if it was already 0. And that was the hardware instruction doing that. So made life fewer instructions. We didn't have clock rate, but we had fewer instructions for everyday operations. It's kind of fun.
Okay. That's the end of my story anyways. And that's
Yeah, that was a good story.
A few points
Yeah, right.
to check out.
Let's see here. I can throw up an AA update. I went down this funny path where I made all my primitives as if they were wrapped but not boxed, and I'll make a distinction. The wrapping was I act like you were a struct that had fields, and boxing is that actually turned into memory. But I made the primitives not actually consuming memory. They knew it's strongly typed. They didn't need any memory for this. But I could load against them, and they had fields, and the fields would be the operator functions. So if you did a 1 + 2, I took 1, I looked up the operator plus on them, I got a function out, I called it with the 1 and the 2.
So wrapped just means that it's a type that exists in a type table somewhere.
Yeah, exactly. Yeah, really. And then in the IR, I had it actually wrapping and unwrapping. That was just too bulky. So I've yanked the wrapping, but I've kept the IR hack that says, or the typing hack. So at the moment, my IR finally allows a constant 1 to float up to a load that loads a field, and he'll do the magic check and say, no, you're a constant 1. I immediately switch you to the int class object, which has got a full class-like structure and has all these fields that are final and have loaded with functions, and he loads the function out and goes. We just pulled somebody else up here. Here he is. Sorry. Yeah.
This basically falls out of your model of anything that's static inside of the struct gets moved to the type.
Yeah, right. So the types, like the prototype object is not visible to the user directly, but I secretly give you that as a cost model and throw things there.
So the thing that's interesting about it in 32 is that it's 4 bytes of instance specific data, and then a kind of arbitrary amount of static data that exists in the type table.
Yes, yes. So I can add new operators to things by simply, so I mean, in the appropriate operator table, and operators are looked up by the first argument, but actually it's all the arguments, but it's the first one, the name, no, it's not true. The namespace is for the first argument, and then the remaining arguments can disambiguate overloads. So I ended up at, so like 1 plus pi turns into an int add of a 1 and a float, of an int and a float, which is an operator overloaded on plus versus int plus int. So I don't have a explicit conversion. There's no widening that's being done automatically per se. Instead, there's just overloads that have ints and floats in both directions. A bunch of people just showed up here. It's just like crazy. Fine.
So it sounds like you're going to have fields that you really want to make sure are constant at compile time.
Well, that's the final assignment operator. You do a final assignment somewhere, and then that's.
But you could do a final assignment at any time.
Yeah,
My thought was if
Oh, I
I
see.
want to have something where I say, yeah, at build time, as this thing is being compiled,
So
I want to make sure this becomes a very constant table that I don't have to
Right.
do this math when I load the binary.
Right. So the guarantee is that if you put the code definition in, this is like I need to go to the Google Docs and do code thing. There's a specific code fragment here. Let me share Google Docs. I'm gonna do a demo live of things I'm making up on the fly, so it's gonna shit for demo, but you know, it happens. I got too many windows open. Let me go find, there, that one died. Okay, here we go. Let me get this over here. Sorry, I'm getting there. Google Docs, yes. Share, fine. Okay, so somewhere in the universe, I made the following definition thing, and then I backed it off, but I've actually kept this. So int is declared as a type. So that is int as a variable is assigned finally is a colon. The colon is type. So int is a final type. And he has a bunch of operators in there, and that's the operator syntax for plus. And he's got a built-in this pointer because I'm assigning you inside of a type constructor. So now I'm generating code. So I'm flipping between type parsing and standard expression parsing. And then I have a $Java, you know, frame here for this guy. And then there's another one. This is the
Dollar just means escape to the native platform, or
yeah, escape to the native platform. I actually put a full Java class name here, and I'm not writing it out, that does int plus int. So I'll do int making an int, and here's the Java prim that's like a int float making a float. And then I do all my other primitives. So that exists. I actually was parsing that at runtime for a while at the start before I did anything else. And I backed off that and I just automatically generate that. So I don't have to do it at startup, parsing the int class, but I can just drop things into that declaration right now and add new things into the int class. And same for floats and so on and so forth. Where did my Zoom people go? I lost my Zoom picture. It's fine. Yeah, and so it kind of was a fun feel, and I like sort of how it works. It's like everybody, then you use this code here. So use this code in a sentence here. So 1 plus 2, under the hood, this translates to 1 does the plus operator gets turned by the parser into a lookup of the underscore plus underscore field, which is then called with an argument 2. So that's syntactic sugar. So all my operators become syntactic sugar for loading a field on the left argument, then making an instance call of the function you got loaded from with the other right-hand side argument. And it's all checked for that you didn't make a bad thing when you set up and built it and use it, whatever. But all your operators land this way. And you can add operators to other classes and fields, and they'll do the same thing here.
And that int just follows normal scoping rules.
And the int just follows normal scoping rules. Yeah. The scoping rules that you don't see here is I do start of the universe before you get to see anything, the prims get loaded and they are at a top scope. Then there's a file scope, and the file scope is inside the top scope, and that would be whatever you declared at file scope. And then scoping follows from there. So there is a hidden top level scope that's got this definition in it for the ints.
So the scopes are like the language and then some scope owned by the core libraries and then your program.
The language has an int, then you have a file scope. Within file scope, you might import something. As soon as you import things, like math is in the core library. So secretly up in the universe somewhere, there's also a math is equal to, and it's not a type, it's actually a module, if you will. Pi is equal to 3.14, and I have a rand.
What's the difference between a type and a module?
Module is just a struct, literally a struct. And this is, returns an int, so random number generator and things like that. So math can be used like this, math.pi, right? So it's just a struct, and so you do struct things with it.
So this amounts to an object.
Yes, yes, an object.
Mhm.
A C style struct, a C style object, class,
Yeah.
Java object.
Yeah.
That also shows up in the, secretly in the primitives in the world. I'll have a sys in there I don't have right now. They'll have things like system.print for print line, but sys.cpu count and sys. Whatever things you will need to have in a system level stuff for timing and profiling and whatever other things that you might want to have user exposed but declared. So the int and the math both show up in the prims at the top level, so you don't actually see this code, but it's available as if it was written just like that. So let me go.
It's like the prelude in Haskell.
Yeah, yes.
The code you automatically get imported at startup.
Yeah. Right. Yeah.
But does
okay,
that
fine.
prelude need to run every time I start the application, or can I do some kind of like this stuff gets run at build time and just the results get stuffed into binary?
It is as if the prelude ran, but or of course it just bakes down to like some constant somewhere, so there's no execution cost to start. But the behavior I'm going
Right, I'm
for,
thinking of closure, which takes a long time to start because the first thing that happens when you start it is it builds the world.
okay, my claim is that this will all be executed as if it was, I'm sorry, it would behave as if it was executing, but that I can hard guarantee this bakes down to like nothing, constants in a table, and will take nothing but load time. Like the int is a type declaration, there's no code for that.
Yeah, I'm curious what amounts to. It can be seen like an interface with the methods. It can be seen like the class in Haskell with a bunch of methods, like a dictionary.
Yeah, yeah.
Mm.
It is as a type. It defines a record type or struct type for the ints. But I could have a record type called list that had a next in a field, or a dictionary that had a get and a put. It's just a record. I'm sort of swapping freely between record and struct for people. It's just a collection with fields that have named offset, that have named fields that have whatever values they want in there. In the case of int, I want them all to be final so I can hoist them off to the side and they're not carried as part of the payload. But another field here that's not a function might be this, right? Whatever you do for max int. So that's not a function, but it is a final constant. So it also gets hauled off to the side. And then using these can also be used this.
And assuming no one in the program actually calls that thing, it could probably be boiled away entirely.
Int. Yeah, int is a type, so there's no code, so you can't call it.
Right, but I'm thinking if you had a program where people are using ints all over the place, but no one actually takes an int and does int.maxint.
Oh,
then maxint is now dead and can be eliminated.
That's the optimizer's job. So yes. As far as I'm concerned, the semantics are int.maxint exists and has the following value, you can use it. However, the optimizer goes to town, gives you as if semantics. If it's dead, fuck it, you can't see it. You don't know if it's there or not. Optimizer deletes as dead, yes. So dead code elimination should work on these just the same as anything else.
So what happens if you write one.maxint? Does it still give you the maxint or?
Yeah, it does.
Okay.
I went back and forth on this and I kind of don't care, but as far as I'm concerned, one.maxint should work just the same. You can also write int.plus. That gives you an argument that's not been pre-filled in on the left-hand side and assign it, you know. So here
So
is a local.
a number of languages will make you put the one in parentheses just because they're trying to make the parser a little simpler.
Parser doesn't care. My parser doesn't care.
Who cares about the parser? Goodness, you write that once.
Yeah,
because
well,
the thing that comes past the dot will
no.
only ever be a number if it's a decimal and will only ever be a letter if it's a field.
Right. So I know it's a field load. then I'm going to field load against the left-hand side. If the left-hand side is of type int, then the field load does the prototype lookup off the int prototype. If the left-hand side is lowercase I here, int is a type variable, then I have a special hook, but that's on the load operation, not on the parser per se. I've already generated a load of the field max int. The left-hand side is either going to be an int or it's going to be a type, in which case it'll be some value or some type. If it's a type thing, then I'm gonna, do the lookup one way. If it's a value thing, I'll do the lookup a different way. Whether it's an int or you have a different, entirely new class you made that is unrelated to all other classes.
That implies that 3 can never be a valid name for a field in a struct.
That is correct. 3 is not a valid name for a field in a struct. Secretly, tuples will use 3, and it is legal to say .3 on a tuple. So if I do, x, y, z dot, well, this is 0, 1, 2 dot 2, I'll take that and give you the value for z. But you can't make your own field called tup.
Okay, so either the fields are all numbers or none of them are numbers. There is no, my fields are A, B, and 2.
Either you're a tuple and all your fields are numbers, and a tuple is simply a struct, and all the fields are contiguous numbers starting from 0 going up, and there are no other options about it. Or your fields are normal field name things, and you're not a tuple. So only tuples get this treatment.
So for uniformity, should I be able to say array dot 2 and get the third element of the array?
I haven't decided if I want to go there. I'm liking, square bracket syntax. So this is this versus this, right? And are tuples arrays? And I'm not settled on tuples being an array. If they become an array, then yeah, the array.2 will work. And I don't have any reason that the parser won't care on that one. Well, the .2, he does a hard check. The left-hand side is known to be a tuple. I guess he doesn't. He just uses a load against the field too. No, the parser won't care. Yeah, parser doesn't care. He'll give you a load against the field called 2.
My only comment, the array suggests that the thing on the left is uniform, which isn't necessarily true of tuples. So I don't think you want to interchange those two notations.
Okay, when you say the thing on the left is uniform,
like a tuple. A tuple can be an int, a char, a string, and who knows what, right?
Yeah, right. Yeah.
And so array doesn't seem to make sense for that case, right? The array notation doesn't.
Oh, the array notation, because you're expecting homogeneity.
Yeah. So
right.
To some extent, array is a subclass of tuple where everything's the same type.
Yeah.
Okay.
Right. I'm still screwing around with arrays because I've started there, and then I'm about to come to, I want all my arrays to be standard members of structs so that you can do the hack that you do in C, where you have a trailing variable length array and a leading set of constant fields. And then array doesn't stand alone unless it's inside of an empty struct with the last element being the array in question that you're dealing with. I don't know. I haven't sorted my arrays to the end yet. No, but this was a Dan that said that, was somebody said, or Keith said this implies homogeneity, which tuples do not.
No, the array syntax suggests people are
used to the first one. It's the bracket 2 that implies homogeneous. The .2 implies each of these to be a different type.
It's just a human thing. There's no reason your language can't change the rules.
No, that's entirely fair. I mean, a part of the issue is in a language is you have a weirdness budget. You can only do so much weird shit before people look at you funny and cross their eyes and go away.
So that kind of brings my question. When is AA going to be, the most popular language on the planet? How do you see us getting there? or when?
Yeah, right. Well, that's a roadmap, and I don't have any time scale on it. I keep going round and round on discovering new things, either typing or implication stuff. I kind of think I've settled out my typing game. So that was a year-long, side trip. I'm now busy trying to imply, oh, here's Jim Northrop finally showed up again. Let me, oh, I have to stop sharing to go find people again. Oh, admit, I can do it this way. Here we go. Yeah, I don't have a roadmap and I don't have any rush. So if I had money, I would hire somebody and that would go somewhat faster. There's a lot of stupid things I make for decisions that I try for a while and play around with, and then discover I don't like it and I back out. It costs me some time. And if I had another person to say, hey, this is kind of dumb, what the hell, you know, I'd probably not make so many mistakes. But I'm having fun.
I thought that's what this coffee compiler club was for.
Well, maybe I don't like dragging everyone into this thing, but maybe I should drag it in earlier. The fun thing was parsing the ints at startup time and going and once I had the original setup going, which took a little while, I could throw in all the operators and then add new operators, sort of writing AA code. That felt good, looked good. The overhead was that during debugging normal everyday shit, I had extra wrapping layers and unwrapping layers everywhere, and it made it slow and difficult. So I yanked it, but then I kept the first main concept I kept was, hey, I can just have an int and treat it like it's an address when I do a field load on it. If I teach the load guy that he should bounce off to a class. And the next one was, oh, ints have a class object or a prototype object. I'm calling them prototypes, but they're a class object more or less. They're not a Java class per se, but they're similar flavored. So that's where I'm at right now. That seems to be working okay. I keep running into other funny issues that are non-obvious. Here's an interesting non-obvious one. I don't know where that. I got a weird cursor. Oh, I see. Somebody put a font doing manual fonting. Okay, fine. I see. It wasn't a font thing here. So some function takes an x and a y and computes x and y. Okay, what is the type of this function? So it turns out that it's a function type where x is typed as a struct, which supports the operator, supports an operator in there, which is itself typed as a function which takes an a. I need to put an a here. This is a. And ampersand doesn't know shit, so it's whatever y is, producing some c thing. What the heck? Where's the L coming from here? I don't quite have this type right. And then this is a b, and then it returns a c. You get something bizarre like this. Like int doesn't appear in here at all, because the operator doesn't care, and I can make a whole unrelated type. My int is a type.
Apply to bit sets too, or any kind of set.
I'm sorry?
It should apply to sets as well.
And most CRDTs.
There you go. My set. Right.
So yeah, it works if if X has an ampersand operator that understands the other argument.
Yeah, right. And that so my tests, which start out by not doing this, by saying, oh, ampersand only lives on ints and ints only live on ampersands or whatever, suddenly fail. So I'm like, oh, a bunch of my tests are going to fail for this. I'm off like sorting out, does this make sense? Is it legit? And you guys just said, yes, it is. It makes total sense. So, that's good validation. Means I'm on the right track. I'll go hammer it some more. I have like several hundred tests. Little snippets, and
the thing that it makes hard to express is that certain functions should be reciprocal. A and B is not necessarily B and A, if this is your definition of and.
Yeah, I don't have a way to say that the function is commutative.
Yeah, and there are going to be some that aren't. Like you think matrix multiplication, a good example.
Right. Divide.
But I don't think you'll find many people surprised by this. You think of C++ templates. You don't explicitly declare that your arguments have an ampersand operator, but you just use it, right? Yeah, and then the template is applicable where it exists.
Yeah. Okay, good. One less notch on the weirdness budget. If I can blame C++, I'm all happier.
I mean, that's sort of how the very duck-typey Python like languages do it.
Yeah, but they do the lookup, right? They look up on the fly.
In C++, if the template is not applicable, what does it give you? A runtime error, or because the templates can be expanded at runtime? How does this work?
I assume you get it.
What templates expanded at runtime? Not C++.
You said that you can attach the ampersand here in the template, and it's applicable where it has a you pass it a class that has an ampersand. Is this correct? Am I understanding this correctly?
These are all compile time.
Yeah, you get
structures,
compile time
as far as I
error.
understand.
Oh, so if it doesn't have the ampersand method, it's a compile time error.
Yeah, that's what I'll give you too.
Hmm.
So if I can say in here, say, 3.14 and 2, that's gonna report, error, float does not have a right.
I have a question. So your array operators, do you support multi-dimensional
Arrays?
access for array operators?
Yeah, so I
You have a
haven't,
syntactical support for multiple dimensions.
right, I haven't decided what to do on multi-dimensions here. The Java solution of you just nested them, but each individual inner array was its own separate array, obviously has interesting performance implications over a true multi-dimensional blob of contiguous data. So in particular, the ability to directly address without going through the in-between stage array can only happen in Java if the garbage collector and the JIT conspire such that the array subarraylets are forced in order contiguously in memory, as if you were a giant two-dimensional array already. They just happen to have object headers in the middle of them all. You can do all the array math like normal and it works, but that sort of blows the purpose. Why the hell did you have an inner array if it was forced to be laid out, can't be garbage? It's not ragged. You can't have a ragged array or anything. It has to be all forced. By the way, the operators that you're writing there, the underscore goes where the operand goes. So the traditional bang operator has its argument follow it. So you would put the underscore after the bang, not before. So that's to say,
I usually think of bang.
Unless it's
So
a
bang before tends to be not, and bang
Not.
after tends to be factorial.
okay, I'm not putting a factorial in random things, but you might put it in my set. Math might have a factorial. The standard language does not have a factorial.
Right. So my question is, can I have my, I'm defining negate by putting a minus before the underscore? And can I define factorial by saying I'm going to have?
Okay, so negate is also defined the same way, like this. So this is run the negate operator on the number 1, giving you a -1.
Right, but
And of
isn't
course
this
you could do,
backwards?
minus, 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 and it works. So as soon as you put a postfix operator on there, then I have to go, I haven't got the parser working properly with postfix operators. So this is an operator you're trying to say this, dun, 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 and how do I parse that? And that's my
Right.
question. And I don't know yet I can parse that.
And
I know how to
particularly,
parse
are you going to get yourself in trouble if I have
a minus operator?
some operator B that doesn't exist as an intermediate operator, but is a prefix operator on one of them and a postfix operator on the other one of them?
Right, exactly. So right now
They're going to need precedent rules for that.
Prefix operator has some strong requirements that if it's a multi-digit prefix operator, like say minus minus, somebody says, I want minus minus prefixed. So that's 2 minuses, and it didn't show because Google
Turned it into a wider dash.
turning it.
Yes, if you say minus minus, it's like, you mean M dash, right? And you're like,
Yeah, right. And
No.
no, I don't, because I'm the fucking Roboto font. Like, goddamn, I'm doing code. There's a code thing also somebody found the other day. Where the hell was code in here? One of them somewhere, normal text had a code thing. I can't find it now. God damn it. Fine. So yeah, courier new. Somebody just flipped it. I flipped courier new. Let me show courier new here. Quit playing M dash. You have to put a space in there. Fine. Fuck it. Anyhow, if you did an operator that had multiple dashes, I give it up. Hey, I cheated it, got it around. Then I get confused with a single leading dash versus multiples. So I disallow them. So as soon as you have multi-character prefix operators, all trailing suffixes of your prefix operator have to be unique against all leading characters of all other.
Okay, so the rule is operators must be prefix free. No operator can be a prefix of or suffix of another operator.
It's not quite that rule. It's a little more flexible. I have it heavily documented here in Oper now. If I go find, Google, Microsoft did me an update, so I lost.
So if there are no spaces between the characters of your operator, then
Yes.
you ought to be able to support like negate and pre-decrement, both, right? So minus and minus minus.
The problem I have there is, do you mean 3 negates in a row versus do you mean a negate and a minus minus?
But it depends if there's spaces in the usage.
If somebody writes as a usage, the dash 2, okay, I have to cheat on them.
Yeah.
And let me come back and see if I can cheat on them. How do I did this the other time. Yeah, okay, so somebody says this. So there's a clear minus minus with spaces. This is not ambiguous.
Right.
Somebody else comes along and says, and he's taking leading minus. Think, oh, I see. I have to back my way into it. Okay, somebody does this with no spaces. Then I have this question, how do I parse that?
Yeah, it could be the decrement of the negation or the negation of the decrement.
It could be 3 negations in a row.
Well, you tell your scanner to either be greedy or not, right?
Well, what I decided to do with this scanner is say, you are maximally greedy and you must be unambiguous. So I say, this is the what you see there, that form is disallowed because it's not ambiguous. So I want to throw an ambiguous error at you, even if the scanner has a hard rule that says I will be maximally greedy. So I don't like this. This is, you mentioned earlier, things you don't like, it implies, I don't like this because it looks too ambiguous. So as long as I'm saying no.
So as long as people have a way out, by using parentheses or spaces or something, then
yeah, right.
I think that's fine.
Whatever, maybe back into here.
So
you
the
could
general
do
trick,
this.
the general trick when you're trying to avoid it is you just build another layer into the BNF.
Yeah.
Where negative, like an int is defined as plus or minus of a int 2, and an int 2 doesn't allow the leading plus, or it's like you basically make it so the BNF doesn't allow the ugliness to go together.
Well, that forces you to know the grammar in the scanner, which I argue is not a good idea.
What happened to the priorities of the parser?
By scanner, so if you mean lexer, yeah, that's fine. The lexer is not supposed to be doing the grammar.
Okay, so hang on. There's like 3 things running around here that are confusing. First of all, under my set, somebody added the word self. I am not adding a self parameter. I'm just giving you one. So there's no syntax that has the self there. You just get it. I might put a dot there that says I want to have the self operator or not as an argument, like dot as an operator name. That's optional. I haven't figured that one out. I don't like that at the moment. I'm not using it, but I might go there. It makes it obvious that you get the operator or not. You get the leading argument or not. Separately, I have a hand rolled recursive descent parser. My scanner and my parser go hand in hand. I don't have a separate lexer, but I do have a point in the parser where I have to look at characters and decide what the fuck do I do with it. In the case of operators, I want to know that I have found the correct operator without understanding the types, but I do get to look at the surrounding context. So in the case of the 3 dashes and a 1, I don't like it because I have to fall back on the rule that says minimal greedy or maximal greedy or whatever for the what you call the lexer. Yeah, my lexer has to decide this.
So
okay, I don't like
that. Have you defined a fixed set of operators in the language? Like
no, but I have defined a fixed set of operator priorities.
If I come along and write a type that has a triple dash prefix operator, that's okay.
No, because I will declare the triple dash to be ambiguous with 3 leading dashes. And so that
not-
operator will be disallowed.
Well, not if I'm applying it to my type that specifically defines that.
I have to, at parse time, without knowing what your type is, because I don't know the types yet, declare what operator I have. So what I'm not doing is putting down a variable parse situation where the final operator selection depends on the types, but the types depend on what operators I ended up picking on. So I have to disambiguate the operators without knowing the type. So what you said is legit. If I could know that I had a triple dash on your special type, it would all work. But
So-
I don't know that I have your special type yet. At the time, I'm staring at triple dashes. So if somebody comes along here and writes dash, 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 instead of a 1 there, I wrote dash, 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 food. Okay. Is this a triple dash application or not?
So that was my question, right? So either the language says that you can't define such an operator.
It says you cannot define this operator. There are
Okay.
many operators you can define. This is not one of them.
Okay,
For
so
instance, this is an operator you can define. The leading dash with some pound signs. That's okay.
okay, so you lost me a little bit. I mean,
Okay.
in a long time ago, in a past life, we worked on a language at Cognos where you could define operators in source code, like, not predefined by the language.
Right, right. You can define
Um,
operators. Yes.
In hindsight, I think that was a bad idea, but
Okay.
at the time we tried.
Right. Yeah, everyone thinks it's a bad idea, except that everyone does it. And sometimes in very narrow situations, it turns out to be a good idea.
So anyway, so it exactly has these ambiguity problems that we're
Yeah.
discussing.
Right.
And so I guess I'm now unclear on what rules AA
Yeah.
has with respect to
Right.
the operators you can and cannot define.
I will throw a link to the file in the GitHub repo,
Yeah.
which has the discussion of what and why.
So
And I can
If
give
you-
some more examples. It's not hard. The examples are, I think, reasonable.
if we use spaces to separate separate operators,
Yeah.
then I don't see a problem with letting somebody define the triple dash operator, because you can only use it if you don't put any spaces between any of the parts of it, right?
Well, as soon as you say I have a triple dash operator, so I put a link in, and it's the link number 4 for my discussion of what an operator is allowed and why. As soon as you say I have triple dashes, immediately I am allowed to parse it as 3 unary minuses. And you're just like, oh, but I can have spaces or not. That lets me tell apart that your intention is to do the triple minus here. Like if I wrote 3 minuses in a row, and I knew that 3 minuses was allowable as an operator to some type in the universe somewhere, I have to parse it as 3 as a triple minus, as a triple
Yeah.
dash. Okay.
And I'm arguing that that's reasonable.
Okay, as soon as I do that, and you have the 1 there, like the example where I say, I don't like this, that code becomes illegal. This case of the triple dash and the 1 is illegal because ints don't support a triple dash operator.
Yeah, well, that's a semantic decision, not a lexical decision. That's
Yes, but this means that pieces of code that I can write in C and in Java and in Python and in Fortran and many other languages are now disallowed. I can't say minus, minus, minus 1 because it might be a triple dash for some type I've never yet seen. Therefore, I parse it as a triple dash. Therefore, it fails because the number 1 shows up.
Well,
and yeah, I don't understand your objection to that failing, I guess.
Okay, I would like code that I can write sort of normally in many languages to also work in AA, because that's part of the weirdness budget, the surprise budget. If somebody says -1, I get a -1. I say minus minus 1, oh, I get a +1. I say minus 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 1, I get a typo error. I get a syntax
Okay.
error.
Well, I would argue that you're already sort of far enough away from from many
Okay.
languages. The notation of operator definition is for one thing, right?
Well, how you define
Underscore dash underscore is how you define the binary subtract operator, right?
Yeah,
Like,
and that's because
I haven't seen that in any other language.
Yeah, I went there because it defines in the name of the operator where the arguments go.
No, I like it. I'm saying, so if
Yeah.
you're already very different from other languages, and so I'm not sure why you're stuck on trying to.
One is defining an
retain-
operator, one is using the operator. And
Right,
I'm trying to keep the using the operator to look like normal everyday C Java code, as long as you're only using normal everyday operators. If you make a weird ass operator that looks totally weird, then you did, like my minus dash dash, you did, and it behaves like an operator. So I can, whoops, what did I do here? But that's, you've already defined an operator and using it in a use it like this. Actually, this isn't a valid operator syntax because it needs to have the underscores floating around. So there's an operator being used as a separator character, as a separate operator, as a binary operator.
sure. So I think the summary though, you still have a priori decided which kinds of operator definitions are going to be allowed, right? Like at the language level.
There are some limits in what you can do.
Yeah.
Well, I mean, I'd argue what's weird is having triple dashes in a program. Like, I don't think there are many C programs or Java programs that use triple dashes.
Oh, there's no common everyday use case for triple dashes as actually 3 unaries in a row. This is somebody screwing around because they can screw around. I'm with you on that one. So the argument is really, I'm trying to limit the weirdness budget. If I write shit that writes in C code reasonably well, or Java, like the intersection of C, C++, Java, Fortran, Python, you write the same code in AA, you'll get the same semantics. That's a design goal to limit the weirdness budget. So if I say 1, I get a 1 out. If I say -1, I get a -1 out. If I say -1, I get a 1 out. If I say -1 in all of these languages, I get a -1 out, not a syntax error. And that's the goal. Now you can add other operators that do all kinds of other things to them, but the rules are, I threw the link to the rules, that there's some reasonable amount of flexibility involved. But there's definitely limits in order to not harm any existing code. Like, if you don't define the triple dash operator and somebody has a program that has 3 minuses in a row, I guess that one's obvious and it's already too late. You can't define it now.
Well, I mean, like what I'm doing is I don't have a weirdness budget. I have a migration budget. So like the question is, how hard is it to rewrite all the C code into all of my code? And so the way I'm going to do that is I'm going to provide a translator program that literally you run it on the C code and it translates it into my code. So like, I mean, so as far as this, I mean, it's like, it doesn't really matter how C defines the semantics, because you can easily just add parentheses and it doesn't really change the
right. Yeah, I'm still right. I hear you. I'm still in the zone of, I want it to read like you expect it to read and write kind of how you expect it to write, given there's a weirdness going around. Whereas the translator is a whole another step that says my language is convenient for C to translate into my language, and I'll provide you a tool to do that. And I've used these tools and they suck in the input and the output, and they suck, but they get the semantics mostly right. The code is unusable at the other side typically because it's
Well,
too much
that's the
translation.
point I was going to raise. Again, back at Cognos, the product first started, it was written in SPL, an HP specific language.
Mhm.
And as they wanted to expand the platforms they supported, they wrote a translator to C.
Mhm.
And then after that, future development happened in C, and the code was just ugly.
Yeah.
I don't wish that on anybody.
Yeah. Yep. That's sort of where I'm sitting on this particular case. Now, the thing that I've done with operators that I really like that no one's bringing up is the thing of doing balanced operators, where I'll let you write wrapping primitives or wrapping operators. Where the using it looks like, E0 is wrapped by E1 or whatever as a use case. And the nested parens behavior is preserved by the definition of the operator. So square bracket, round bracket, angle bracket can all be used in an operator where the expectation is the brackets are balanced, or the requirement is the brackets are balanced, but that you could have something before, in between, or after the brackets.
I like the idea generally. It feels weird to me in the times when you have an equal sign in your match.
Yeah, right.
Those are the
So
ones that I look at that and go,
this
seems.
This is done the same way. The array operator is exactly this operator right there.
Yeah, that's the only one that weirds me out, is the sticking the equal in the pattern that you're matching. I want
Okay.
the equals to always mean I am assigning a thing, and if
Right.
equals suddenly can mean I'm firing the missiles, that feels odd.
Okay, so what it means is I'm making a function call that's expected to have a side effect. So here's one. This is totally valid in Python, right? Same exact syntax. It's just that the lookup happens on a dictionary thing instead of on an array thing. I find the operator and I call the dictionary put version, which is, this is like basically put. As opposed to an array store operator. With Python will totally let you do that dictionary assignment, so will JavaScript.
Yeah, we do the same thing.
Yeah, okay. So that's your missile firing right there. You did a put.
Well,
Yeah, that's true. In Python, I absolutely can make an object that if you say open parentheses string key close parentheses equals val, that can do arbitrary behavior.
Yeah, it does arbitrary thing. You call the Python operator the under put under operator, where they have a named operator you call. That's what you get out of that. And then it side effects usually, but you can make it say printf. Hey, what the hell? You're writing to the to the dictionary.
And you don't allow any spaces in one of these pattern definitions, right?
I'm sorry, the operator name as written in the assignment declaration has no spaces. The usage can have spaces. So on all of these things, spaces are totally free. The two halves.
Yeah, Cliff doesn't like this.
In that case, I would add the rule that when you are defining an operator, you must have a space at the end of your operator pattern.
When you're defining it, the definition here.
So like the myset example, slightly higher up. If I don't put the space after the underscore, ampersand, underscore, and before the equals, is that still valid?
Well, you have to carry on parsing after that. So let's go look at this guy here without the space. Do I mean to have an operator that has a trailing equals and a piece in the middle and a prefix piece? Okay, but now what's the next piece of valid syntax? Well,
if it's an equal sign, then
I have to do this. So it's unambiguous when you define it. So that definition is not ambiguous to parse it. I claim I don't allow that operator style. I have binary ops, which get a precedence based on the first character. That's not the underscore. I have unary ops. I have balanced ops, which have things in the middle, but they have a balancing bracket, round bracket, curly bracket.
So to have something that's in the middle, I have to have a 3-argument. I have to have a 3-argument function.
You have to have a balanced argument, which requires one of the square, angle, round brackets. And the guy in the middle is surrounded by it. I don't allow this
The
one.
bracket types are special.
I'm sorry?
The brackets are special.
Yes, brackets are special operator syntax. This guy, I think I don't allow directly because he has because the bracket is already overloaded in another context. So,
So if I try to define A less than B less than C.
I don't allow that form as an operator. I will
So
probably
it will
do
break it
something-
down
I
into
even
A
talked-
less than B and then.
Yeah, I talked Cameron into putting that in his language, and I'll probably put that in my language too. So I don't know if it shows up as an operator or not. You're discussing an operator be written like this. And it does a three-way comparison, gives you true or false if these three things are ordered.
Right. Typically, you want that to expand into A less than B, logical and B
Yeah.
less than C.
And only execute B once.
Exactly. That's the big difference.
Yeah. So B has to be assigned a temp
Mhm.
along the way. And I claim that as an operator, that one doesn't let me have 4, 5, and 6, 7 of these things. So I'll probably not do that. I'll probably have some screwball thing with relationals that are special. So you can write A less than B less than C, and that'll be semantically converted into A less than temp gets B executed once less than and temp less than C.
Yeah, it's
Like that.
important not to confuse the parsing of an operator with the operator.
Yes. And here I'm claiming it's two operators, but I don't like the parsing yet, but it's two operators being parsed. And the parser is stitching the two operators together. The other piece about that one as a single named operators, I might want to have equals on some or more. I can have a chain of A less than B less than C, D, E, F, G with equals or not all in there. And I don't want to have a unique operator named for each one of these varieties.
And you don't want to have A is less than B is less than C is greater than D.
And yes, and that's right. Yeah. And then the parser will blow that out too. It should blow that out. So this becomes a kind of a parser special. He says you have a comp style operator and you have a second comp style operator and you have a missing expression and I will auto expand you just what I showed and let you carry on with those operators. But he'll call two operators there.
Okay, that sounds sane to me.
I'm trying to think how to generalize this. And so I'm thinking along the lines of A less than B returns a pair, a Boolean and the value of B. And then that tuple type has the less than or equal operator.
Well, I have a mix of less than and less than and equal.
Yeah. So I mean, so you define the mapping from, the comparison to this tuple type, right? And then that tuple type has less than and less than or equal that can be applied to the next argument, returns the same type that can be applied to the following argument and so on.
I claim that's what the parser is going to effectively do.
Yeah, well, I'm saying,
but you're saying
build it into the library rather than the language.
Right.
That in my mind, that's better.
So your head is something like the parser breaks this up into like some sort of tuple and another pair of less than less equal and less equal and less, and he makes a call to math.conf with this set of things, something like that. I mean, I'm not doing this well.
No, that's not what I meant.
Okay.
So I'm saying break it up so that A is less than B. Instead of returning Boolean, like you might first think, can also return, well, maybe Boolean is augmented with,
The type
think of,
B.
so the A is less than B is a pair, right? The value true or false together with the value of B. Okay. And then that pair type has a less than or equal operator that can be applied to C, returns another instance of that pair type, and so on.
I'm trying to I'm
So
trying
you do it
to.
like one step at a time.
Yeah. Because you also want to abort halfway through if you want to early short circuit if you fail early.
Yeah, so if you apply less than or equal to the pair type that's false comma some value, the answer is false. You don't evaluate the other argument.
Yeah, that's roughly how you compile it.
Right, and I'm hearing him say, I want this to show up in the library somehow, and I haven't, I mean, I'm still like screwing around with syntax and semantics. Like
Yeah.
less than B is a curried function that takes one argument and compares it to B.
Right.
So the first one happens, now you have a result. If it's false, you bail. If it's true, you apply it to the curried argument, which is less than or equal to C, or something like that. I'm not positive. I think, I'm sorry, but I think I'm going to be cheesy and wimpy and do the thing that I wrote right above. Because I don't want to think about it.
Well,
Sometimes,
yeah, I mean, so what I'm saying is that you have an augmented Boolean type that pairs the value true or false with that temporary.
Yeah.
Okay. And that expanded Boolean type has the less than and less than or equal operators that can be applied to another value, the same type as, the temporary that it holds.
Right.
And you just keep going until you get the answer you want.
You still have to lazy evaluate the extra arguments.
Right.
Like the and syntax for me says the right-hand side, it's an operator, but the right-hand side is done lazy. So the parser wraps up the right-hand side in a thunk and passes it as a thunk to the and.
In a completely lazy language, you get all that for free, but.
Well, you get it automatically, but it's never free. There's a real cost to it. I claim, right, semantically,
Okay,
I want to do the
right,
lazy
right.
thing on the right-hand side of and.
Automatic, perhaps not free.
Yeah,
Okay.
right. But in my cost model, I want to give you the hard guarantee. If you say and there's a right-hand side thunk, the thunk gets peeled apart. And and if then else happens. I think that's a reasonable hard guarantee to make.
Yeah.
Okay. What other weird things am I doing that I can go bang on you guys for? Right now, I'm just sorting on, I'll make my test here, but I had to do some other.
Have you thought more about how you want to do either snapshotting a program so that it can be resumed later or on a different box?
No, that's a runtime hack. I'm not there yet.
In that case, I would throw out Lvalues and rvalues. And what do you want to do for passing around pointers?
Yeah, right. I let that one slide because I was thinking I was going to sort everything else out here. In fact,
But
I
if
have this
a preceding ampersand and preceding asterisk are part of your Lvalue system, how does that interact with these?
Yeah, hang on. I'm going to throw out. Here's a sample test case from AA. Exactly what the triple dashes shows up as a sample test case. Like, what the hell am I parsing this as? And there's another version of that where I just drop the one off and it's illegal because I'm missing the following expression after the final unary guy, but actually knowing that that's what the hell's going on is an issue. Okay, so then there becomes L value versus R value as a question. I was trying to find what other syntax grief things I had to change recently. It's right now, it's just in functions where I wasn't expecting the my set behavior to appear and it did, and I was surprised. So my test golden rule was all wrong. Yeah, L values. So there's a funny deal that says L values are essentially a fat pointer with the base and an offset, and you can generate them in a lot of ways. Suppose I allow arbitrary currying. Why did this not? There it goes. And I look at an array expression. So I have an array expression like this means I get a value out. and I put it in some X variable and life goes on. I hate the auto cap thing. Okay. But if I do array index equals with a value, I get a store. But if I just do it like this, then I'm calling a curried operator with one argument missing. Now I have an L value in the middle of an array. This semantically, I'm not claiming I'm doing the syntax or I believe it. This is me like, hey, let's talk about L values. Right, and the similar operation happens totally on the dictionary side of thing, which I have no idea how to do this, right? Because how do I store into the L value? How do I use the L value in a sentence? Well, usually use an L value, you say L value is like star equals, right? Star equals L value equals, you know, val. And so that there's this weirdness is like the dictionary one hurts me because it means I have to define a dictionary such that I can take an L value of a key slot, the value assigned to it. But if I have like a non-blocking hash map, that assignment does weird shit. You can't do a normal assignment there.
Yeah, I want to question why you want to do this at all, because the dictionary may have some invariants and you can arbitrarily mess with those if you have an L value to some internal state of it.
Yeah, absolutely. Absolutely. So you know, same can be said about arrays where I hand out a pointer to the middle of an array, someone wants to assign to it. Anytime I have a structure, I'm going to do arbitrary assign. Dictionary is harder because the notion of what's it mean to be a mapped value is not so straightforward as an array. And in particular, people will have chains. They've got walking chains of linked lists for key overflows, or the reprobing is variable, and I'm holding a slot open, and the reprobe would fail if it knew there was a key there, but there isn't one yet, or a value there, or whatever. You look at concurrent hash map, and some of the chains of linked lists of assignments will go dead over time because he knows that you're writing, or you have to take a lock to do a write under concurrent hash maps. So I cleaned it. The notion of L values does not scale past address of a structure element and address of an array element. And so kind of I'm leery of making this special type in the universe for just these two pieces. So
in the general case, what if you don't store any kind of internal pointer? You just store the pointer to the base object and either the integer that is the index into the thing or the string that is the key.
So then I went to this other version of L value where I said it's a magical tuple like this, right? And there's no point for it being anything except just a fucking tuple. It could just be a tuple. And then I have to use it reasonably. And so I need a special, oops, supposed to be L value here. So I need a special thing, like if star is a prefix operator that expects an L value, a 2-element tuple, and it is a function which is defined to be, I take a 2-element tuple, which I'll automatically unpack for you. So we'll call this the, I don't know, the base and the index. And then I will call the appropriate store operator base of index. Oh, and you're going to call it with it. It's actually an operator has a, let's see here, has to have a value. It's a prefix value. There we go. Doesn't have the word L value. It's a prefix star operator. And I'll put spaces in here to make it clear. I'll call the operator. I'll do this. So L values are just a tuple. There's a star operator, which takes an L value, breaks out the tuple elements, and I could, in fact, invoke the syntax this way if you prefer. Actually, I probably have to do that. I don't do my magical array unpacking for arg call arguments directly in this case. Okay, so so you call it, define the star operator like this, and then you can make an L value, and it's just a syntactic sugar for missing the last argument on an assignment dude, and you get this tuple back of the 2 arguments, which you can then apply to a star. But
But does it have to be more than syntactic sugar to empower CAS?
There have to be some other syntactic sugar I claim to do a CAS. Because this guy, no, this guy is simply syntactic sugar for adding the third argument to the square bracket operator. Ultimately, everyone's calling the two square brackets with an equal operator. Now, what that operator does in the non-blocking dictionary, he does a CAS. But doesn't a bare array, he inlines down to an array address math and store like you expect. So maybe this is a better version of Lvalues. And whether or not the L value that you get is opaque typed and under the hood, it's secretly a tuple that you can break it out, or it's actually like a fucking tuple and you can just say L value dot 0, L value dot 1 to go pull the bits out. And you can make up an L value. Hey, let me grab this thing and that thing, put them together in a tuple, poof, it's an L value. These are all open questions, you know.
And I could get arbitrarily aggressive with that. I could have an object that is my like SQL database reference, and the key is a query.
Right.
And
That's
when
the
you try to
lookup
access the
version
thing,
for
like-
L value. So there's a lookup version for L value that I didn't do here. I did the lookup version, which is this one, which does the, you know, so here, cut and paste. With this, right? There's the lookup version. If you don't even need the semicolons here, through those. So, yeah, totally. So somebody comes along and says, you know, my query is equal to some SQL evil, comma, I don't know, table, right? And later in life, someone says, contents of my query. Well, that returns me the result of the table. Oops, what did you do there? There you go. There. Oh, I can't spell query either. And what you got out of that was that star as an operator applies the square brackets on a 2-element tuple. Type error to be 3-element tuple applies square brackets on a 2-element tuple. And the star equal version applies the, you know, the 3 square bracket equal version, 3 argument version. I like this one and because it's like complete and it's easy. Oh, Bill Venner's finally showed up. Dang, dude, we're like done. What the heck? Somebody says typo. Oh, no doubt. Oper was thrown together last week. I'm certain there are. I am just as certain there are typos there. Line 51.
Put it in an issue. I don't, the assert on the next line seems to expect the 2 characters are different.
Oh, probably. Oh, I'm fairly certain there's some confusion going on here. I will stare at what you wrote here offline.
Yeah.
But yeah, you're probably right. And like I said, I slapped that sucker down, and I don't have all the operators turned on yet, so I haven't tested any of those either. Like I have tests for square bracket array lookups, not currently running because I'm not getting through much earlier tests on function syntax headers, which were blowing up, like I mentioned earlier, where I discovered that the ampersand operator can now appear in any arbitrary function, which totally makes sense when you said it. Hey, set operators want an ampersand. Oh, fuck, of course they do. So there you go. And,
Yeah,
and Bill Venner's just arose, I think. Actually,
getting L values into a language as a first-class concept can be quite challenging.
And your suggestion is?
Well, I mean, we have a solution but you know, it's hard to suggest a solution without kind of a total picture. So
you have a solution that's different.
Right. Yeah, our L value is just another object. So
Yeah, in Java, this would just be a consumer of whatever value type we're talking about.
Right. The way I'm defining the L value is it's just another first class. I mean, it's just another object in the normal base language here.
But the solution we have is, it's hard to get your mind wrapped around if you're not kind of down in the assembly level. But the idea is that while everything is an object, you never actually touch an object. You always work through a reference. And so an L value is just a reference that happens to be
Are you going to use the CCC document, or I'm going to flip back to, I'm going to stop sharing?
I wasn't planning to.
That's fine.
So for us, an L value is just a reference that happens to have a method, type safe method for setting the value. And so
Okay.
that way you can expose a piece of data either as an R value or as an L value if it's settable. And so it applies, equally well to an element in a matrix or an element in an array or an element in a dictionary or a local variable or property, and so on.
Yeah, I don't distinguish most of those,
Right,
but you're not distinguishing them here either.
right. But it also allows the same thing to be implemented by, I'll just say downstream developer, meaning someone who doesn't have access to, who's not doing the language design directly. So it allows you to simulate via code the same concept by implementing that interface. So an L value is called a var and an R value is called a ref,
Yeah, fine.
as in variable and reference.
Right.
And the idea is that a reference represents a referent. It represents a pointer to a referent.
Right. Yeah.
So, and what the nice thing about it is that it bisects. So I'm going to try to explain this, but I'm not sure I'll get it right. In Java, everything's on the object itself.
Yeah.
When you have a referent separate from the reference, you get to move some of that capability to the reference itself and leave some of the capability virtually on the object itself. So you get the separation between the reference and the referent. So the referent is a thing with properties and methods and so on, and the reference is the lens that you see it through, if you will. Right. So so that allows us to put the type information onto the reference through which we see the underlying object. It also allows us to associate the identity not with the object itself, but with the reference. So we were able to uncouple the identity from the underlying object, which is something, if you talk to Mark or Brian or any of the guys on the Java team, it's one of the things they wish they had done before releasing Java 1.
Yeah, I kind of have a different take on that one. In my head, there are times when people care that they have alternative meanings for equality and times when they don't. And that because of that, I'll just say, if you want to have a different meaning for when it says that two guys are equal, or they have the same identity or they don't, you have to define it. That's usually done by putting something in the equals, with defining an equals function. And I don't know that it's perfect, but I think that's a reasonable thing to do. If you don't define an equals function, you get a default meaning for what it means to be equals, which for me boils down to essentially pointer equality for pointer things, and value equality, which is bit for ints and floats, and collections of ints and floats that people are declaring as a value and not as a struct, or not as a.
There's something to be said for keeping equals equals different from .eq.
Yeah, that's what I'm doing. I'm claiming equals
Something to be
equals.
said for not having .eq.
I hear you, and I'm thinking I want a .eq, and you're saying I don't. And
Well, I'm saying we have, like I said, kind of the solution has to fit together as a whole. So in our case, we don't have the .eq per se.
Right.
We have an equality that uses the compile time type. So if I have two maps for sake of argument, and I say, map 1 as object equals map 2 as object, then the compile time type is object of those two references at
So
that
you
point.
use the object equality.
So we use the object equals, right?
As opposed to a map equality, which might do, they have the same keys, so they're equal.
Right.
They have the same keys, same values.
And we also have ordered map, right? And so, and this goes back to kind of one of the pain in the keisters in Java is the, you know, left equals right is different from right equals left.
Ah,
So if I have a sorted map and a map, I'm going to get a different answer if I say left equals right versus right equals left,
yeah, right.
or I get an exception.
Yeah, 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 but you're
And
not.
here we do
tran-
all the
inclusive.
exception checking at compile time. And then we encode, even if it's a formal type, we encode the compile time type to use at runtime.
But it means that at the compile time, you're picking which version of equality you're using.
No. No, we're simply encoding what we know about the compile time type at compile time.
Okay, so at compile time, I hand you a thing which is capital O object, but in practice, it's going to be some map or other,
Sure.
sorted or not, you don't know what. And then I say equals, or I want to compare them for equality. At this point, you know only that it's an object because I only handed it to you as an object. So you'll use the object equality.
So it will encode the operation as being equality of two objects.
Yes. So the reason I'm coming there is those maps each have their own notion of what it means to be equals, and they're different and unrelated to each other, and they'll fuck up if you alternate them. If you mix an ordered map and a map and you say, are you equals? The question's not well formed, right? So
Right.
it's screwed up.
Right.
But it's also not capital O object equals either. And that's some confusion here. I want to know, I want to see if there's a way, or I don't understand how it plays out or why it plays out better to say, I'm going to use capital O object here because that's all I know, which is a fine answer. But
it's because the developer said that's what they want, because they have two objects.
Yeah, so the developer says, I'm calling a hash function with two objects that internally the keys have to be compared. The hash function is a generic library routine, doesn't know fuck from fuck all, and gets only objects, that's all he knows. The developer knows damn well I'm handing in two sets of keys for which they each know an equality test. I would love it to be transitive or commutative, and they both have the same set, but maybe I don't know that. And I'm handing in objects into this hash table. Okay, what are you buying here? And which comparison is getting used? From what I heard you say, because the library hash table doesn't know shit from Shinola, he only has capital O objects, so it's all objects. He does object equality, which is almost surely the wrong answer.
Yeah, I was talking to Brian Getz the other day on this topic, and he likened it to Haskell's type class concept. So in that it's not a virtual function, and I haven't used Haskell, so
Yeah, fine.
then I know what I'm talking about. I intend to use it now just because he inspired me.
Back on point.
But it's not a virtual call. It's not a vtable call.
Right.
The equality is not a vtable call.
You called
but,
dot, yeah.
but nor is it static. Right?
Okay.
It's based on the compile time type. So the compile time type gets encoded. So at runtime, the compile time type is looked up for the equality operator. Then that equality operator evaluates to a function, not a virtual method, but a function. And so then that function is used. So it's what it means is that if I have a map from list of int to collection of string, and I compare it with another one, I will actually deep compare all the way down. So the maps will compare as maps, but the keys will compare as lists of string, and the strings will compare as strings.
Okay, hang on.
It's a dictionary, basically. I mean, in terms of Haskell type classes implementation, what you basically have are dictionaries. And if you implement for last type class like equality, which is for equality comparable types, then the equals is going to be still dispatched at runtime. But what you are passing is the dictionary, which is basically like a struct containing function pointers to the relevant dynamic types of the objects. So neither of the objects has a built-in vtable. It's rather a structure that you pass separately. at least in the
Well, it's
GHC
a
compiler
type.
for Haskell.
For us, it's a type. We have three things for an equals. We have a type, we have a left side, and we have a right side.
Okay, so
So
the type is
basically
the
you have
same
a-
for them both.
You have a dictionary in the type, is what you're saying,
Yeah,
right?
that's what I heard. You did a
I don't-
lookup at runtime. You didn't call it a vcall, but you said you did a lookup at runtime based on,
Yeah, runtime in quotes. I mean, that could be at link time. But if it's a formal type, then it actually has to get deferred until the formal type can be resolved.
well, I'm talking about the most common obvious case is I have a shared hash table in a library that everyone in the mother is calling. And everyone's calling in with different types. And what do they pass in? What I'm hearing now is I pass in a vtable of the equality choices and a left and a right. And it's one vtable for the two guys. That's key because it means that we don't care which one came first. You have nailed down the one. So this associativity or commutativity problem goes away. But now there's still some lookup that is done at runtime to decipher which version of equality to use. And I keep hearing you saying, no, it's not. And then I hear you say, but we do a lookup at runtime. And I'm like, you do a lookup at runtime or you don't?
Right. Well, so for example, take a list, right? So I have a list of T, a list of element, right?
Okay, so hey,
So list
my
define
example,
equals.
my example
List
says
of-
I have a hash table which wants two keys and you're going to compare them without knowing fuck all about them. All right, in your next example, are you saying replace the hash map with just a list, or are you
I'm just
saying
trying to simplify the example. Yeah. exactly.
one key is a list and the other key is something else? Or no, you're saying start from a list.
So I have two lists of T,
Okay,
right? So
Okay.
how do I pick the equals for T?
yes.
Well, I can't pick it at compile time. So it's encoded as list of T, but at runtime, there's actually a value for T.
Yes.
So at runtime, if I come through this code 10 different ways, I may have 10 different T's.
Uh-huh.
So it's going to take 10 different paths. So yes, in that case, the lookup is deferred until when it knows the type.
So you do a runtime lookup for the equals operator, but you only use one runtime lookup for the two T's. There's a left list and a right list.
Oh, they have to match. If it's not the same type, it doesn't compile.
Okay, so the left T and the right T have matched at compile time, which is reasonable. I'm okay there. That's fine.
Well, we know that they're both list of T. We don't know
Yes.
what T is, but we know that they're list of T.
And it's the same T.
Yeah,
Yeah, okay. For instance, an
it's the
example
same
where,
formal. It's the same formal type.
yeah, the example where I wanted to compare a ordered list with an unordered list, or an ordered map and an unordered map, but I don't care. Those are not the same T unless I toss the order notion away.
Well, they're
It's
not the
just-
same. They're not the same. One is a map, one is an ordered map. So,
Yes, they're not
so
the same.
we would not allow that to compile.
Yeah, you not like fine, great, compiler. And if I took the ordered map and said, oh, it subtypes the regular map, I can go up once.
Yeah.
Now I'll be ordered map to ordered map, an unordered map to unordered map compare,
Right?
and that would compile and be okay.
Correct. Or you could do it the other way and type assert. So what we dot as,
Yeah.
I could take the map and say dot as ordered map, because I
Right.
know it's an ordered map.
And,
you know, between-
and then that would be you putting a runtime type assertion in to strengthen the type
correct.
or doing the equality check, which is fine also.
Right.
No surprises here. There was one other piece.
Right.
Do
But it's
you
also,
do you
it's recursive.
automatically find the least common ancestor in the type hierarchy, or are you required to upcast, downcast, or throw away information? I have an ordered map and I have a map. I'm calling somebody who's going to compare them. He demands equal T's. They're not. They have a common ancestor. Do you find the LCA or not?
no, we don't, because we're using the compile time type. So in other words, what does the compiler know? Like,
The compiler
think-
knows them all, and the compiler can do an LCA right there. This is a compile time knowledge.
yes. But I'm saying it has two variables, A and B.
Yeah.
Those two variables, to compare them, they have to have the same type at compile time. So think
Literally
about
at the
it.
same time. Okay. And if one is a subclass of the other, that's not good enough. The user has to declare, oh, treat this ordered map like a regular map, and then do the compare.
Right. In other words, the declaration type, I'm trying to simplify it, but the declaration type of the variable A if it doesn't match the declaration type of the variable B, then
Oh, I
I couldn't
see.
compare A to B.
Okay,
So
okay.
say I
So,
have two parameters in a method, A and B.
yeah.
They have to be the same type of the parameter. The objects don't have to be the same type. But
I
the
got it. I
parameter
got it. I
types
got
have
it. Okay. So I had a different, I had a slightly, we're closing in here.
Okay.
If I've declared one to be ordered map, declared the other to be regular map, and there's a known hierarchy that says ordered is a subclass,
Yep.
you'll still say, no, not
Correct.
good enough.
Correct.
Instead, I have to say temp equals normal map of the ordered map. Now I have two normal maps, the right-hand side and the temp, and I can go compare them.
Mhm.
Okay, fine. This is a different, interesting decision. I'm not claiming, some of that I really like. One of them is equals gets only one decision point and it relies on them both being the same, which then gets rid of the whole problem of,
Yeah, I've never seen the approach used. I mean, I wrote it up on the blog a while back.
yeah, I didn't understand the write-up to
Yeah,
be
it's 'cause
what
I'm a
you just
sucky
described
writer.
to me.
But yeah, it's so far it's worked out perfectly. Like it hasn't
Okay.
had any downsides.
And you don't feel the lack, you don't feel the hurt of having to constantly upcast people to get rid of knowledge.
We never do it. We almost have
Okay.
no casts in the whole, like in 100,000 lines of code, we have like no casts.
Okay, cool.
I mean, almost. There's a
Yeah,
few
yeah.
in the database and a few in serialization, but you'd expect that
Yeah.
because it's all reflective
Okay,
nonsense.
yeah, that's fine. Well, that sounds good.
So
Okay, so that's fodder for my thought process.
it's fun.
Yeah.
But you know, you've got a different model too, in that you've got both reference types and value types.
Yes, and I've come around to allowing bulk collections of value types to be a larger value type. So value types are not just ints and floats,
Right.
but any collection, including fixed size arrays. It's all fine.
I mean, that makes sense. Sets of values are a value.
Yeah, right. But then I still want to have a reference type. And I want you to know the difference and deal smartly, require you to deal smartly with the difference.
So
Because-
we did introduce a new craziness this week, a new crazy wrinkle this
Uh-oh.
week. We introduced transient.
So what transient mean?
I use Java's transient, but for unrelated thing, I thought it was a stupid thing. Fine. Okay, great. Carry on.
So our transient allows a property on an otherwise immutable object to be mutable, but it cannot permeate the service boundary. So basically, it's like a cache. It's like you can use a transient as like a hidden cache, so you don't have to.
Does cannot permeate the service boundary mean nothing outside the service can see the transient data? Or
It means that each
once
service,
something outside looks at it, it's no longer immutable. It's no longer mutable.
it means that each service you pass that value to, its transient portions would be wiped clean as it goes from one service to another.
Interesting.
So it's kind of like deserializing and having transient fields. And
So if I
and the reason-
deserialize and serialize back, all the transient data got wiped out.
Right. The reason it's handy is because, so for example, if you profile hash map, a dictionary in any language, hash dictionary, 47% of the calls use the same key as the immediately preceding call, right? Like in Java, for example, you're not allowed to call get unless you call contains first. I'm joking, of course. You should never do this, but in reality, developers say if contains X, get X, right? And guess what it does on get X? It does every bit of work that it did on contains all over again, right? So a trick I've always used is on whatever my internal find key method is, I cache the last key and the last entry. And I check it by identity. I mean, there's no reason to even like do equals. It's like, I just want to straight through.
Yep,
If it's
yep.
the same thing, here's the same answer, right?
Yep.
Now, so I have a hash map and I pass it to another service. So hash map is freezable. So behind the scenes, it gets cloned, and the clone gets made immutable and passed across. Right? This is just the way it works, right? So freezable is a contract that says, if you ask me to become immutable, I may have to generate a copy so I don't screw up whoever tried passing this thing, right? So it passes across an immutable hash map, and now I try to look up X. And it's like, okay, I found X, so now I'm going to store off the last key I looked up and the last entry I found, and I'm going to store it where? Well, somewhere hidden inside me, except me is immutable. Kaboom.
One advantage of this state existing on your individual objects is now when an object is misbehaving, you can turn it off and back on again and see if that fixes it.
The old saying, they're the two hardest problems in computer science. One of them is invalidating of caches, and it's exactly what you're targeting here.
Well, yeah, and skip list map is the other one that has the same issue, because in a skip list, you try to reuse your storage area. Part of your storage area is your head node. Part of your storage area is your, I should explain, we can do an entire skip list with one allocation. So because we use an array of elements, array of ints, if you will, some size int. And so all the nodes are laid out inside that. So a node is just an offset into the array. So it allows us to have an extremely efficient allocation for skip lists. But one of the things is every time you do a find, you need the same size node as the head node. So if your max, has anyone written a skip list, or am I just pissing into the wind here?
No, I use non-blocking hash map for roughly equivalent
skip
things.
list is such an amazing structure. You got to check it out.
I certainly read the papers. It's fine.
Yeah, they didn't make sense the first 50 times I read them, but now it's like, man, this thing is so cool. It really is. So the only reason I know about it is because someone replaced one of my custom built red-black trees with an AVL list, and then they replaced it with a skip list.
Yeah.
And so I learned both just by having my code thrown away. Anyway,
Excellent.
My code was thrown away for a good reason. It was leaking pointers and corrupting data.
Back up.
Anyway.
Yes. Anyways, no, I was just thinking the invalidating of caches, like you're avoiding sending across the wire or returning back. You're actually, what I heard you say was, we're simply pulling off the freezable, the defensive copy is guaranteed here, because I gave a defensive copy, handed over to the other guy who busily like fucking mutates the hell out of it, even though it's in theory it's immutable, because he can hack on these transient fields. But I don't get to see that because I don't get the transient field back whenever it comes back.
Right, for example, exactly. So it's kind of, it's like thread local, but it's more service local than, because we don't have threads. But yeah, I don't know, Mark, do you want to say anything about it?
Mark on still? A bunch of people have Mark's, maybe.
He
50-50,
might be.
he's getting his kid from school. He always bails out a little early to go do kid errands, which I was there, I get it.
This COVID thing lets people work from anywhere.
Yeah, the new world order, except that sometimes it sucks. All right, fine. This is surely spam. Let's wrap it up. It's 2 o'clock. I'm 2 o'clock. 2 hours. I'm ready to go eat lunch. And I kind of think we had a great conversation. I haven't sorted out all of your transient yet. I think there's something to be done there yet.
5 o'clock somewhere. Yeah, it's an interesting one, and it's we've still got issues to figure out in terms of performance, because one of the reasons for having the immutability is to not have to make copies. But now I have kind of the immutable portion, and then I have kind of part of it glued on that gets mutated in one way in one place and gets mutated in one way a different place.
Well, everybody
they can't overlap.
Yeah. So the whole thing has a property that there's a temp tucked off to the side that's not part of the immutable copy that everyone has a thread local storage on, but without necessarily as much syntax as I want a thread local storage hack for my cache and yada yada yada, service local storage, whatever. How do you do local cache.
So-
Yep.
And everything's deep. So immutability is deep, cloning is deep, so it's
Yeah.
like all those,
Yeah.
and it does make for some interesting challenges.
Yes. Yeah. I haven't gotten my multi-threading thing sorted out yet, which I've had talked to people who say you must do freezing, immutable, deep copy cloning games, because then we can do private heaps per thread, and then we can do it's all immutable. So we'll just pass the pointer around, unless we have to make the copy, and then it sucks. And so the cost model gets all weird on you, and I haven't
Yeah.
sorted that one out yet.
Yeah.
Let me know when you get the Spectre-like timing attacks working so you can leak data between your divided
Exactly,
worlds using
exactly.
these caches.
Hey, he cached. Oh, he didn't cache. Okay, that was not the right key. Let me go ask for another one. Oh, he cached this one. Okay, that was part of the last thing.
Well, the key to defeating Spectre is first make your code really slow, and second of all, make it completely unpredictable in its execution
There you
performance.
go. You have to have it be like not monotonically slow. You have to be uniformly slow. It is always equally slow no matter what you do.
Yes, it's kind
Or
of
just totally unpredictably slow.
it's kind of like
Oh yeah,
some of
okay,
the
or
early,
completely unpredictably. Yeah, that works too.
kind of like
Making
some of the early
Terraform,
risk chips
making-
where every instruction took one cycle, so you had to your fastest instruction was slowed down to the speed of the slowest instruction. Do you remember this?
Yes, I lived those years.
I'm making careful notes to say what that the code I'm committing is just Spectre mitigation. Thank you, Cameron.
Excellent. That's my next throwdown squirrel. My old ex-wife worked at a power plant. When the power plant went down in the 80s, they would lose $1 million an hour in the 80s because it brought offline Dow Chemicals plastics facilities. So it was insane amounts of money. So if the power plant went down, and they produced way more power than the city of Houston consumed back in that era, like way more power. So if the power plant went down, heads rolled, right? So the throwdown squirrel was like the throwdown gun for the cops. Oh, a squirrel jumped across the high tension line, fried himself, and fell to the ground dead. And they pull out a dead squirrel. Not my fault. Squirrel did it. Sorry, my lexicon includes throwdown squirrel as a thing that's stuck in my head forever.
And just one shout out. I saw this week someone did a write-up of a bunch of kind of the 2021 recap of programming language stuff. And I can't remember his name right now, but he comes to this call quite often. Footmark.
Oh, Footmark. Gosh. Yes, I have it on my inbox. Where did he go?
Yeah. So he got mentioned in this write-up. I saw
Yeah.
write-up. I'll see if I can find the link.
No, it's an interesting variant. He's doing heavy analysis of array indices, type safe array indices for doing multi-dimensional, really real array games with type safe array bounds.
So anyway, it's just going to give him a congrats for getting someone's tracking and excited about what he's working on.
Tolls. Gosh, I can't remember his name right now. I gotta go find it here. Actually,
Charles Hendrickson.
Tolls. Yes.
All I could think of was Will.
You've made it when someone puts your language on one of the bricks of the Tower of Babel.
Yeah, I'm not there yet. Tolls. Atas. I keep getting his email confused with his first name, Tolls.
That's
Yeah,
the
okay.
one.
Yeah. All right. Boys, good conversation. Somebody throwing in the leading, citation list to start an open conversation worked totally great. I don't know if we got to all the const expert CCP did not make it to the top of the list. Darn it. But we had a fun start anyhow. You missed Kirk going down his tale of woe and despair. It was pretty good. All right. Till next week. Bye.
Bye.